Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the next problem on changing order of integration with evaluations. So this is our question, change the order of integration and evaluate. So now if you see in this limits, we have the variable y. So this limits will be for x and this limits will be for y. Since x limit has a variable y, so the first integration is with respect to x and the second integration is with respect to y. So now we have to change the order of integration, so we will change the order. First we will integrate with respect to y and then we will integrate with respect to x. So we have changed the order. Now we have to draw the diagram. To draw diagram we need the first limits of integration, that is x equal to y and x equal to 0. X equal to y is a straight line passing through origin. X equal to 0 is nothing but y-axis. So we will draw these lines. So we have this line that is x equal to y and this is our line x equal to 0. So x equal to 0 and x equal to y represents the lower and upper limit of the strip. First we are integrating with respect to x, so we will consider strip parallel to x-axis. So we will have some strip parallel to x-axis. So the lower end of the strip is on the x equal to 0, which is matching with this, and the upper end is here. And limit of y will represent how we are going to move this strip. So we are moving this strip from y equal to 0 to y equal to a. So let's say y equal to 0 is x-axis, so we are moving this strip from y equal to 0 till y equal to a. Let's say here we have another line whose y coordinate here is a, so this is y equal to a line. So we are moving this strip from this point till this point, so this is our region of integration. Since we have changed the order of integration, now we will consider strip parallel to y-axis. So let's say this is our strip parallel to y-axis. So now the lower end of the strip is on the line, so we will have y equal to x and the upper end is on the line y equal to a. So these are the lower limits and upper limits of region R for y. So y is going from x to y equal to a. If we have to cover this entire region R, so we will move this strip from this point, we will move in this way till this point. So we have to find what is this point. This point, at this point we will have x equal to 0 because it is y-axis. And at this point we will have x. Why we are writing x? Because we are moving this strip in this direction, and in this direction the value of x is changing. That's why we are going to write the limits of x. So what is this point? This point is nothing but intersection of this line and this line. This line is y equal to a and this line is x equal to y. So we put y equal to a in this equation, we get x equal to a. So this point is x equal to a. So we are moving this strip from x equal to 0 to x equal to a. So these are now our new limits of integration. So our equation will become integration of x going from 0 to a, y going from x to a, x dx dy upon root of a square minus x square, a minus y, y minus x. So first we are integrating with respect to y. So the terms which containing x will be constant. So we can take these terms outside the integration. So we will have integration of x going from 0 to a. X upon root of a square minus x square will be constant. Y equal to x, y equal to a dy upon, and in the denominator we have a minus y and y minus x and dx. Now if you see, this is a very complex integration. So this is a very complex integration because in the denominator we have a minus y and y minus x. So we are going to do some type of substitution. So we substitute y minus x equal to t square. Then y will be t square plus x. Then dy will be 2t dt. Why we are putting y minus x equal to t square? Consider only this term. So we have dy in the numerator, so 2t dt, because dy is 2t dt upon root of a minus y. Y is t square plus x, so t square plus x. This is a minus y. Then we have y minus x. Y minus x is nothing but t square.